My name is Mr. Ademujimi Adedoto. We'll be looking at the topic called current electricity. What do you mean by current? Current electricity is equals to charge over what? Time. Charge over what? Over time. Which we can easily say that what? Current equals to charge over what? Over time. Which can be given as current is the rate of what? Of flow of charge around the what? Around a circuit. I'll take that again. Current is the flow of what? Of charge. Is the rate of flow of charge around a circuit. What do you mean by time? Time is the rate at which an event is being measured. Okay? Which you know that the unit of what? Of charge is what? Is coulombs. Charge. Q is charge. Charge in coulombs. In coulombs. And T is what? Time. In what? In seconds. Time in seconds. Okay? So we can say that I equals to Q over T, which is equals to, the unit of this is what? Is C over what? Over S. S as in seconds, that's the unit of time. So we can say that this is still the same thing as coulomb per what? Per second. Current is coulomb per what? Per seconds, which you can say that what? 1 coulomb per second, 1 coulombs per what? 1 coulomb per second is equals to what? Is ampere. Is ampere. Is ampere. 1 coulomb per second is equals to ampere. That is 1 coulomb per second is 1 what? Ampere. Are we together? So we know that this is given by what? This. So which you can have what? Quantity of charge, that is Q, equals to I times what? Times T. That is equals to IT Q. That is that. Okay, from there now we move further to from current electricity. So let's move to potential difference. Okay, before that, let's look at some symbols. Electrical symbols. Electrical what? Symbols. Electrical symbols. We have A, that's ammeter. The second one we have voltmeter. The third one we have what? We have galvanometer. 1, 3, 4. We have this as resistor or this. Okay, or this. For the fifth one, number 5, we have this also. We have this. This is what we call a transformer. Transformer. And what again? We have variable. We have variable resistor. We have variable resistor. Okay? This is what we call variable resistor. So number 7, we have cell. This is variable resistor. Variable resistor. This is what we call cell. Okay? This is resistor. This is what we call galvanometer. Why this is what we call voltmeter. This is what we call ammeter. Okay? This is cell, right? So what do we mean by ammeter? Ammeter is an instrument or a device used to what? To measure current. What about galvanometer? Galvanometer is an instrument also used to detect little amount of current, small currents in a circuit. That's the difference between this and this. This is ammeter, this is galvanometer. While voltmeter is an instrument used to measure what? Voltage. This is resistor. Is the amount of opposition offered to the flow of current in an electric circuit. This or this, and this is transformer. It performs the work of what? Of stepping up or stepping down of what? Of voltage. This is variable resistance. Why this is what? Cell. Okay, this is cell. It's different from battery. Okay, so arrangement of this of two or more discs in series or in parallel is what we call battery. Okay, is what we call battery. So the next thing now is to move to what? To circuit. What do you mean by circuit? Circuit is a closed path. A closed path that allows the flow of electrons. The closed path that allows the flow of electrons. Something like this. Let's say we have, this is the what? Resistance box. So this is a battery voltage this. So whenever we're having what? Load, this is taken as what? Load. In a circuit, this is a circuit. You can see, this is a circuit. Why do we call this circuit? Because this is a load and there's what? Applied voltage. So current must flow. So current must flow. So since current will be flowing through this, so this is a circuit. It's a closed path. You can see, a closed path that allows what? The free flow of what? Of current. Okay? Before I forget, you see another one again that we call key. Key. This is what we call key. This is used, it's a device used to what? To break and to make circuits. That's the function. To break and to make circuits. To break meaning that, let's assume that we're having what? Key here. Key. You can see that. Let's assume that we're having this here. The function of this, that's key, is to break. That is, when this is open, you can see the key is open now. What happened? It means that it will block, that is, it will break the current that's supposed to be flowing towards the side. Okay? So once you close the key, you can see the key is closed now, so there will be movement of what? Or current or electrons moving in the circuit. So this is what we call circuits. Next thing now is to move to potential difference. Potential difference and EMF. Potential difference and EMF. EMF means electromotive force. Electromotive force. Potential difference, that is PD. What do you mean by potential difference? Potential difference is the work done to raise one coulomb of charge from one place to another. The work done required to raise one coulomb of charge from one place to another. That is potential difference. It has symbol V, okay, and it is measured in volts. In volts. In volts. While EMF is electromotive force. Normally, EMF is not actually a force. It's not force, but the function it performs in a circuit is to drive what? Is to drive electrons. Is to drive electrons, which can simply be defined as the what? As the voltage between the two terminals. Between two terminals of what? Of battery. When current is not flowing, the voltage between the two terminals of batteries, when current is not what? Is not flowing. Okay? When current is not flowing, that is EMF. EMF is also what? Measured in what? In volts. Also measured in what? In volts. Okay? So let's look at what? Internal resistance. That is internal resistance. Internal and external resistance. External resistance. Internal and external resistance. Internal and external resistance. What do we mean by internal resistance? External resistance, the function it performs in a circuit is to what? Is to determine the maximum current that EMF will be what? Giving out. That is the function, to determine the maximum current that EMF will be giving out in the what? Circuit. Let's take for instance that we have, okay, we can use that symbol or we use it, but I prefer using this, okay? Alright, okay, this is small r, which is the what? The internal resistance. Why this is what? Big R. This is the external, and this is E. That's the EMF, which is what? The EMF. EMF is what? The voltage between the terminal of the battery when current is not flowing. That's it. When current is not flowing, the voltage of the battery or cell when current is not flowing, that is when the circuit is not what? Delivering any current. So the voltage, so that is the EMF, okay? So let's go. So this is the external resistor, where R is the internal resistor, okay? And R, that is big R, is external, is the external resistance or resistor, that's it. R and small r. What is the function of this? I'll take it again. The major function of this is to determine the maximum current that this electromotive force will be what? Producing, supplying to this circuit. Don't forget I call this circuit because this is a closed path where what? Current flows or where current passes. So it's a closed path. So this is the circuit. Are we together? So the function of this now is to determine the maximum current that this will be giving out. Okay? So which you can simply say what? The relationship between them as I equals to EMF over what? Over R plus what? Plus R. Are we together? Over R plus what? Plus R. So if you have this as over 1, you can cross multiply. This will be I into bracket R plus R equals to EMF. So you can have EMF equals to IR plus what? Plus IR. Okay? Are we together? Are we together? So that's the circuit diagram. Okay? This is the circuit diagram. So let's look at what? Example 1 under this. Example 1. Okay? Example 1. Example 1. We're having a what? A circuit of, alright, this is 6 volts. This is 1 over 2 ohms. And we have this to be 5 ohms. Okay? What are we asked to find? Find the current. The current I flowing in the circuit. So we want to find the current flowing in this circuit. The current flowing in this circuit. This is EMF. Why? Because you can see our external resistance placed close to it. So the function is to determine the current that this will be what? Releasing. Okay? So let's go there. We know that. Bringing out the parameters. What are the parameters given? Parameters, we are given what? We are giving external resistance to be 5 ohms. Are we together? And what about the potential difference? The electromotive force, which is 6 volts. Okay? And we have small r, which is the internal. That is 1 over 2 ohms. Okay? Okay, we know that record that what? That current, which you have to look for, current is unknown, question mark, is equals to E over what? Over R plus I. Are we together? So this will be equals to what's E? E is what? 6 volts over, what about this? This is 5 plus 1 over 2. Okay? And this will give us what? 6 over, that will give 11 over 2. Are we together? And that will give what? That will give what? This will move up. That becomes what? 6 times 2 over what? 11. That is 12 over 11. That will give what? One odd number 1 over what? 11 what? Ampere. One odd number, 1 over 11 ampere. From here, because we have 6, we have I to be equals to what? 6 upon, what are they? 5 plus 1 over 2, okay? Look for the LCM, that will be 6 upon, the LCM of 2 and 1 is 2, 1 into is 2, times this, 10, plus 2 into is 1, times 1, 1, that gives 6 over this and this is 11 over 2. Are we together? So this is still the same thing as 6 upon 1 divided by, this is long division, this is short division, that's 6 divided by 11 over what? 2. Okay? My teacher said that to change this to what? To multiplication, meaning that what? This and this must what? Swap. They will interchange. That becomes what? 6 upon 1 times 2 upon what? 11. Can you see that? Which is equals to 6 times 2 over what? 1 times 11. Are we together? And that gives what? 12 over what? 12 over 11. Which is equals to what? Which is equals to 1 odd number, 1 upon what? 11 amp. Okay? You can as well see what? Convert it to what? To decimal. And that will give you what? 1 point. That should be 1.1. Yes. 1 point something. Are we together? Are we together? So let's look at what? Another question. Okay? That's example 2. Example 2. Example 2. Okay? Find the current. Find current. Passing through the connection shown below. The connection shown below. Now look at the second connection now. Boom, 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 like that. Then we have this to be 1 ohms. We have 2 ohms, okay? Connected, blah, 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 blah. That, da, 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 da. We have this, right? Connected. This, okay? This is 2 upon 3. 2 upon 3 ohms. Okay, and this is 12 volts. Okay, this is 12 volts. This is 12 volts. This is 12 volts. You can pause the video and try it. Okay, so let's go. We're having 2 what? 2 resistors of resistance 1 ohm and 2 ohms. Connected in what? In series. Are we together? We're having what? 2 resistors of resistance 1 ohm and 2 ohms connected in series. This is what we call series connection, or you call it series arrangement. Some textbooks use what? Networking of resistors. Okay? Now, networking, arrangement, or series combination. Okay? So let's go. These are the what? The external resistors. Okay? The external resistors. Recall. Okay, let's bring out the parameters first. Let's bring out the parameters first. Very, very important. Bringing out the parameters to fetch you what? Mark. Very, very important. Okay? This is R1, while this is R2. Yes, R1, that is the first external resistance, while this is R2, the second external resistance. Okay, so we can have the R1 giving us what? 1 ohm. R2 is what? 2 ohms. Are we together? Then we are giving internal, that is small r. Small r, and you know what it does in that circuit? The function is to determine the what? The maximum current that this 12-volt battery will be what? Releasing, okay? That is 2 upon what? 3 ohms. Are we together now? So from here now, we can look for what? For the total. The total what? Combination of the what? External resistor, okay? That will give you what? R what? R external, excuse me, equals to R1 plus what? Plus R2. Yes, because this is what? Series combination. Okay? So this will give you what? What's R1? R1 is 1 ohms plus what? 2 ohms. Okay? And that gives what? 3 ohms. Okay? This is R external. That's the external what? Resistor. Okay? We have the internal to be this, isn't it? We have to find the current. Current is unknown. Find the current passing through the circuit or through the connection. This is the connection or the circuit. What's the current? Okay, the current is unknown, question mark. Recall, very, very important. Write it down the formula, that's AMA. Recall that what? That I equals to what? Electromotive force upon R plus R, which is equals to electromotive force, which is E. E is given as what? 12 volts. So that will be 12 upon, this is what? 3. 3 plus, what do you have here? 2 upon what? Upon 3 equals to what? 12 upon, this will give you what? 3, that will be 3, old number, 2 upon 3, which is equals to what? 12 upon, what do you have here? 9, 10, 11. 11 over what? Over 3. Take this up, that becomes what? 12 times 3. 12 times 3 over what? 11. And that gives what? 60 what? 60 what? That will be 66. 66 over 11. Yes. 66 over 11. 66 over 11, what would that be? That will give us 6 ampere. 6 amps. 6 amps. 6 amps. Okay? Look at this. Because that what? Excuse me. Because we have I to be equals to 12. 12 over, what do you have it? 3 plus 2 over 3. That's 12 over 1. Look for the LCM, that's 3. 1 in 3, 3 times this. 9 plus 3 in 3, 1 times this. 2, that's 12 over this and this. 11 over 3, that gives 12 over what? 1 divided by what? 11 over 3. That's 12 over 1 times 3 over 11. That's what? 12 times 3 over 11. That's what? 6. Oh, sorry. This is 36. 3 times 1, 3. 3 times 2, 6. Divided by 11. That's 36. So this will be 36 divided by what? Divided by 11 amps, or you break it down. Amps. Okay? Example 3. Let's look at this circuit connection. We have to find what this is. Let's take this as 4 volts. Okay? We have to find the total current flowing in the circuit. So what's the total current flowing in the circuit? So if you look at this diagram, it's quite different from the previous one. Okay? You can pause the video and try this. What you just do is find the what? The parallel combination. That is parallel combination. You know, when two resistors are arranged in what? In parallel. This will be what? R1 times what? R2, right? Over R1 plus R2. Okay? That will be this times this. That will be 3 times 2 over what? 3 plus 2. And that gives what? 6 upon 5. Okay? That's 5.2. That's 1.2 ohms, okay, or this. So you can find the total now. R total, what would that be? That would be 2 plus 1.2, okay? And what would that be? That will give you 2.2 what? Ohms, okay? So this is the external resistance, which is what? 1 ohms, okay? So what you just need to do is to slot in the values, okay? So what's the value? Recall that I equals to what? E over what? R plus what? R equals to E is 4 over what? R is what? 2.2 plus what? Plus 1, okay? And that will give you 4 over 3.3, and that will give you what? 40 upon what? Upon 33, okay? And what would that be? The current will be 1.6, okay? 60, and that will give you what? Or you can leave it as one odd number, that will be 7 over what? Over 33 amps in fraction, or you can as well what? Take it to what? To decimal. 33 times 7 is 33. 33 plus 4, that will give you 40 over 33. Thank you and God bless you.